Yep. So hello guys. Thanks for having me here, and I'm really excited to be here today to share my topic with all of you today. So as you can see over here, the name of the topic: live streaming with Google Cloud, and why you should use the cloud for your application needs. But don't focus so much on the actual live streaming portion of this application. The purpose of my discussion today is to show you how you can use Google Cloud to solve for your application needs and how you can use the different parts of Google Cloud to your advantage. So my name is Weiyuan. I'm a Google developer expert with Google Cloud. I'm also an organizer with this organization called Big O Development, which we created this application for. So let's get into it. All right, so I just want to start off by this graphic from, I think it's called Google Cloud in 4 words. And I think this essentially encompasses most of our emotions when we first start out with Google Cloud. There's so many different tools out there, and it's an overwhelming experience when you're first getting started out with Google Cloud. But don't get deceived by the number of tools that they provide. If you need to build something on top of Google Cloud, you just need to look for the correct tools to solve for your application needs. Take, for example, if I'm creating a simple POC that needs a relational database, you could go for a Cloud SQL, which is this small thing over here. Maybe if you want to get a Postgres database set up, you can go for that. But if you are now thinking about scaling up your POC, now you are thinking about millions or billions of users, you might want to go for a more scalable tool like Cloud Spanner instead. Okay? So different managed tools in Google Cloud solve for different problems. So it's important that you find out what are the right tools you need to solve for your application needs. It's overwhelming, but you just need to pick out the right amount of tools. And as a part-time DevOps personnel in my company, I have used Google Cloud for quite some time, and I like to say that it also integrates really well with Google Workspace. Especially if you're using that for the custom Google accounts for your company. Because if you're integrating with another third-party client, usually what happens is that you have to create your own accounts on that platform. You have to tussle around with access control on a different system. But because you are using these tools within Google's ecosystem, you can use the same Google accounts you already created for your colleagues. These Google accounts that you created within your company, you can use that to assign things like access rights for them, for different tools that you have in your cloud project. So it ties in really well, within Google's own ecosystem of tools. Right. So I hope that convinced you, in terms of getting to use Google Cloud. But I want to bridge onto this understanding further by using my current situation as a case study. So why did we want to solve for this problem for live streaming with Google Cloud? Let's learn more about it. Okay, so let's start off with a problem statement. I don't want to jump into the solution directly, but to let you know, why did we need to solve for this problem? And I think it goes without saying that there has been this physical situation that's been happening around the globe where, because of COVID-19, in my current country, we are not allowed to have physical events starting around, I believe, February or March of last year. So as part of the organization that I'm part of, hosting these physical events like this GDG DevFest is something that we want to do for the community. But if we can't do physical events, the next best thing would be looking towards live streaming, live events, doing it online for our community. But there are a few challenges that we face in terms of finding a good live streaming solution. And this, we break it down into 3 portions. Firstly, we wanted to find a live streaming solution that is easy to use. Compared to physical meetups where I get a speaker to come into a venue, there's not much they need to learn in terms of how to utilize the facility. Physical space is there. They just need to make sure they plug in their device into the local projection system. That's it. But in the case of using a online system, there might be some form of barriers to entry in terms of learning how to use the tool. So we want to make sure we find a tool that is easy for our guests to use, as well as for our own staff to use. And also, as a volunteer organization, we also wanted this solution to be affordable because we're self-funding our own operations. So we want to make sure that we don't unnecessarily choose a solution that's too expensive for our monthly streaming needs. Okay, and one very special requirement that we had was that we were working with multiple partners at that point of time. Multiple partners as in the GDG groups in our region So we wanted to be able to stream to their YouTube channels, to their Facebook pages. But this means that we need to find a solution that can allow us to multiplex our streaming signal to all these different locations. Right. So these are the challenges that we face, in terms of in this environment, being able to host a live stream online and being able to stream to multiple locations, as well as these other challenges I've mentioned. All right. So before I go into the conclusion that we need to build our solution, I want to touch on in terms of exploring the different solutions out there. Of course, if we're thinking about live streaming, there are already dedicated solutions out there like using Facebook, YouTube, Twitch. Definitely some of these tools could be explored in terms of to solve for our streaming needs. Okay, but we find that when we compare this against the backdrop of our challenges, it's not exactly, well, it's definitely affordable. Most of these are free to use, but they're not exactly the easiest of tools to start using. Though if you get used to it, it can be very easy to use. Streaming to multiple locations can be a problem because this is the business model of these companies. They wouldn't want you to stream to their competitors. So it didn't make sense for them to provide for these features. So we weren't able to use some of these dedicated streaming solutions for our live streaming needs. So we started exploring around. What if we go with other open source solution? And OBS Studio is something that is very something that you guys might be familiar with if you stream quite often. Especially this is something that you can run locally in your own device. But as we explore into this solution, we started finding that it was also a hassle, to ramp it up, like to get this into our entire workflow. The system doesn't look like it was something that was easy to use. And in terms of getting our guests on board as well, we had to understand this solution inside out before we actually explored it. So that sounded like a lot of work, and we are not sure, whether this investment will pay off or not. So yeah, in fact, it was able to solve, for the earlier issue that we couldn't get from a dedicated streaming solution, which is you can stream to multiple destinations. But we were not convinced that this was easy to use, right? So we decided, why not, let's look a little bit further. Is there any other tools out there or any other solutions? So that's where we chanced on this commercial solution called Streamyard. Just as a disclaimer, this is not sponsored post, but this is just a tool that we are using for our live streaming in our earlier days. And by using Streamyard, we found that it was something that was really easy to use. You can see over here on the right side that there is essentially a live panel over here. You can choose any of your guests or your hosts to be shown within the screen. You can also share the your presentation slides over there. You can highlight users' comments. You can create your banners to show in the middle of the live stream as well. There are many little additional functions on top of the basic functionality that we need, and it was definitely easy to use. And on the left, you can see that it also solved the problem for streaming to multiple locations, right? So did we actually choose this solution? Well, the issue is that it did, to a certain extent, solve our problem in that we're able to get this commercial solution that is easy to use and being able to stream to multiple locations, but it's based on a tier-based subscription. So the lower subscription only allowed us to stream to 3 destinations. And if we wanted to stream to more communities, we had to go for a higher tier subscription, which is, again, not as affordable. So you can see that there's this contradiction between the balance of affordability versus solving for streaming to multiple platforms. Okay, and because we realized that since it's going to be a lot more costly to stream to multiple destinations, this might not be something that we want to explore or something that we can't really use in the long run. So rounding up these 3 solutions, we couldn't really find a solution that meet our streaming needs. And it became a problem where we started thinking, should we start to build our own streaming solution? But that would be very much similar to what you saw in the earlier slide, which is Streamyard, like essentially building your own startup, building your own product. For volunteer organization, we don't have the capacity for going to that extent. But what if we just take one of the earlier solutions? As you see, like all 3 of the criteria, usually they only solve 2 out of 3. So what if we take one of these solutions and create our own wrapper solution around it so that we can solve for all 3 challenges, allowing us to get the live streaming solution that we want? Okay, so going along those lines, we decided to go with Streamyard, given that it was already easy to use. it was considered affordable for the lowest tier. And the interesting aspect is that you could use it, not only stream it to Facebook, YouTube, LinkedIn, Twitch, you could use it to stream to a custom RTMP application that you host yourself. And in theory, we could do this by hosting our own application on Google Cloud and use this application to multiplex to even more applications, even more destinations out there. So Facebook, YouTube, Twitch, all these different destinations can be supported as long as we configure it within our application. Okay, so looking at this enhanced solution, we are able to reach a point where we can meet all these different challenges in theory. Okay, in theory at this point. So in planning, we know that this could work. As an engineer, we wanted to bring this solution even further. So there is this term called vendor locking, and we don't want to lock ourselves in, behind a solution behind a single vendor. What if Streamyard disappears one day, or what if we find a much more cheaper streaming solution out there? Can we encapsulate our solution such that the source can be any RTMP server? Okay? And that's what we did. So we made assumptions and we built the solution according to that. So right now with that solution, in theory, it could take any custom RTMP stream hitting our server, and we can multiplex this signal to all of our destinations. Okay, so this is in theory how it should work. Okay, now the devil in the details. How exactly did we do it? So I want to represent this solution by giving you the entire architecture diagram, as well as to show you a bit of the demo of some of the configuration and settings along the way. So to recreate the entire architecture diagram, we know this is what we need. All right, we have some sort of a custom RTMP source. We need to relay it to our RTMP multiplexing server in Google Cloud, and we'll use that to send to our multiple destinations. All right, so if we're thinking about hosting our own application, there's this question that you have to ask yourself, be it any cloud providers that you're looking out for, you need to think about whether you want to go for, a solution like a serverless solution, in Google Cloud, that would be Cloud Run, App Engine, or even something like Cloud Functions, which is functions as a service, as you can see over there. Or should you go for something that's a bit more traditional, like infrastructure as a service, be it like Compute Engine in Google Cloud, that is getting your own virtual machine and hosting an application directly up there. So there's different advantages and disadvantages to choosing each of these different tools. And it's important that you balance this different solution, find out what's important in terms of solving for your application needs. And in this particular scenario, we had to choose, we had to go with IaaS systems, which is using Compute Engine, getting our own virtual machine. Because for serverless applications in Google Cloud, they do not support RTMP protocol today. So we could only use Compute Engine to solve for this problem. But that's all right. No, we can use that as a base to build our application. So let's replace this part of the architecture diagram with the virtual machine. Okay, and to explain to you what goes on behind this virtual machine, there is an application running in there. It's essentially a Nginx server with a custom RTMP module. Again, this is an open source solution, but we set in the configurations to allow us to do that multiplexing. All right, so jumping a little bit into the configuration, I'll explain a bit on what's going on here. So you just need to focus on line 18 to 25 on this left side for this Nginx config. Line 18 essentially allows us to plug this live stream into proxy forward to a different server and make sure it's authenticated first. Okay, so once we know that this stream is authenticated, because we don't want to have bad actors randomly sending their stream and hijacking our stream. So we want to authenticate the stream source first before we push it to multiple destinations, as you can see from 2022. All right, so this is part of a handlebars templating engine that we're using, because we don't want to hard code our configuration in here. During the brought up of our application, we will render this template out with the input variables to indicate all the different servers that we want to stream towards. Okay, so this is for the Nginx server with the RTMP module. We also have an external proxy, a TLS proxy that allows us to support destinations like Facebook. Because destinations like Facebook only support RTMPS. So that's RTMP with an extra layer of security. Okay, and we can only do this this relay of that stream through external. Okay, we also have a node server, but I'll explain more later on what we use the node server for. All right, so all of this live within this one single virtual machine. Okay, and beyond just bringing up this virtual machine, of course, we also need to start thinking about other security protocols. Like for example, no, I don't want to unnecessarily expose all the ports of my virtual machine and let anybody hit it from the internet. Like I have my node server running on port 8080. That definitely shouldn't be exposed. The only port that should be exposed is 1935, which I'm already doing access control on top of. So we want to make sure that we add in something like cloud networking. So you can see over here on the bottom left, use cloud network to put in the right firewall rules, ensuring that you only allow the certain ports to be exposed to the internet, okay, and thus securing all your other open channels. Okay, so with this one single solution, technically speaking, we have already reached the final portion of our solution. In fact, if I can just bring this up right now, it can do the multiplexing right away. But this is not what we want to create in a production grade application. If you want to build a really good, robust application, we should do more than just this simpler application. Like for example, this virtual machine. If I just bring this virtual machine directly up, install the Nginx server, I'll run some commands on I'll shell in the virtual machine and I will run a few commands on the client. I will manually create the Nginx server and the configurations. All these actions are very manual. Can we simplify these steps, automate some of these steps, and can we create this much more replicable setup? It can be the case where I might have to recreate another new server in the future. So I want to have sort of a easy setup for bringing up this entire application. So in fact, today in the current ecosystem or in the current industry, there are already certain solutions out there that support this easy deployment as well as this replicable environment across, let's say, your development machine, your production machine, your local machine, right? And that's what we call containerization. So you can look towards using something like the container optimized OS, which allows you to deploy a Docker image on top of a virtual machine. Okay, so I'm not just shelling into a virtual machine and deploy my application directly. What I need to do is indicate that my virtual machine is to use this configuration and provide them with this image as you see over here. So this will let them know that this pre-built image can be used to deploy my application, allowing me to get the same advantages as serverless solutions that are already using this Docker image. Okay, and over here, now that we are enhancing our application to use container, to have this Docker image to deploy our application, making use of containerization, another question that you might have would be, where do I save this image? You could have proprietary code that you want to bake into your image, but you don't want to expose it to a public. If you're using a image repository like Docker Hub, I think for free they should provide. They have provided the image repository for free, but those images must be set to private so anybody can access them. So if you have proprietary code, you want it to be private. So of course you can go for paid solutions again using Docker Hub, but that might increase. You might have an additional layer of hassle to integrate, with your systems in Google Cloud. So why not use the ecosystem within Google Cloud? Use something like image container registry as your image registry to store your Docker images. So we can use container registries to store our Docker images and link it to our virtual machine. So every time, going back to this configuration, every time I'm bringing up this virtual machine, it will reference the private repository directly, within my current Google Cloud project. Okay, and they'll bring up the application right away. Okay, next question. If I am already containerizing my application and I know where to get the images from, who's providing all these images? How do I push an image into this environment? Can I have a build pipeline, like some sort of CICD pipeline? Okay, to make our application better, we can make use of another tool, which is called Cloud Build, okay, as you can see on the bottom, to create this CICD pipeline, okay, and couple it with our solution. So this CICD pipeline can be triggered every single time you make a change to your code in, let's say, a GitHub repository on the main branch. If you set a trigger on the main branch, you should be able to get it to trigger a build pipeline to start processing within Cloud Build. And once that build pipeline is done, the last stage could be linked towards building Docker image and pushing into an image repository. So this is what I will be demonstrating here. So you can see in this configuration on the left, we have a cloud build YAML configuration file where there's two stages over here. The first stage is to install the node module dependencies because I have a node server in my in that virtual machine that I'm bringing up. And I also have a second stage, which is to build that Docker image and then pushing it. So you can see from line 15 and line 16 over here. Okay, so you can emulate these stages in Cloud Build, and this is run in series, but Cloud Build is flexible enough to allow you to run different stages in parallel or in series. It's as if you're drawing your own graph of dependencies with each other. As long as you can represent your different dependencies in a graph, you should be able to create that configuration, a very flexible configuration for that in a CICD pipeline for Cloud Build. Okay, and on the right side, you have this this visualization of how your build pipeline will look like. So you have these different stages, this stage 0 and stage 1, which is represented by these two different stages here. So this allows us to be able to see, okay, in one glance, if all of these green check marks are there, that means the build pipeline has passed, is successful. But if a single stage has failed, you can click to any of these stages and check the logs, allowing you to debug and understand if there's any stages that has failed within this build pipeline. So to allow you to fix it before you trigger another new build again. Okay, so this is Cloud Build, a very, very effective tool that you can use in Google Cloud's ecosystem for your CI/CD needs. And we're putting this together for our, as our production in our application for our application needs. Okay, let's move on to another application. Like, how do we make our application more, production ready? Okay, what about secrets in our application? I don't want to bake my secrets. I don't want to commit it into my code repository in GitHub, but I also don't want to bake it into a Docker image. That's not secure at all. Is there any tool that we can use in Google Cloud to store all these secrets? Okay, so you can use this tool called Secret Manager for you to store your secrets. And I'll show you this is the visualization of Secret Manager. You can use Secret Manager to store and to manage different versions of your secret at once. So if I have, let's say I have this code base that's supporting 5 different clients, and maybe there's one single client that is running an older iteration of a code and they don't really want to upgrade to the latest version, and it's dependent on the secrets. So you can hard code the numerical version into your code and only deploy that version to that older client and let them just use that older secret. So until they are ready to deprecate their application, you can maintain that version over there. Just make sure you don't destroy it. For your current applications, you can choose to hard code the latest version, or you can just replace it with the alias, which is latest. Just a latest string. If you put in supply the latest string, they will always try to look for the latest version of the secret and use it as part of your deployment, when you're bringing up your application. Okay, so this allows us to avoid committing our codes and configuration into our code repository, as well as baking it as part of our CI/CD build pipeline into our Docker images, allowing us to have a much more robust application, securing our secrets. And this also allows us to be able to rotate our secrets more frequently. Okay, but now that we are talking about secrets, some of you might be asking, how do I prevent people from publicly accessing my secret manager over here? Like, how do I only ensure that this virtual machine is the one that can access Secret Manager and read Secret Manager? This virtual machine shouldn't be able to write. As the admin, my user account is the only one that's supposed to be able to do this write, as well as reading from this Secret Manager. While this virtual machine should only be able to read, and everybody else should not be able to access this Secret Manager. So to meet that objective, we can use this other tool called Cloud IAM, which is identity and access management, right? So this allows us to be able to create roles based on groups of permissions and assign it to different user account or service accounts. So a service account can be coupled to a production workload over here, where we can assign them permissions like being able to access certain secrets in our secret manager. And then as an admin, I can assign myself the rights to be able to view all the secrets in this project. So allowing us to achieve the objective of ensuring that certain users shouldn't be able to access, like in the for the public user, they shouldn't be able to access my secret manager and steal my secrets. Okay, so the interface itself is very intuitive. You just need to provide the user account or the service account, which is the account that you attach to a machine, and just provide the correct roles. Okay, the roles are attached to, or rather, they are the representation of all the permissions that you want to grant to this user account or service account. Okay, so a very simple way of getting things up. In fact, this ties in back to this other items over here, like the CICD pipeline. If I want to grant my machine, my service account to my CICD pipeline, the permissions to push to my image registry and not let anyone else do it, I can also use Cloud IAM to solve for that need. All right. Okay. Last second portion. How do we make this production grade application, really good? Like in terms of, let's say if I have to build this RTMP relay server, and what if this destination go down? There have been instances where some of these applications do go down, and as a production grade application, if I'm building this for a company, I should create some form of contingency where they can save a video and use it to upload to their channels later on. So we can achieve that purpose using another tool in Google Cloud, which is cloud storage. So you can see over here, cloud storage. It's an object storage where you can take your files, upload in the storage, and use it for further references later on. All right. So within my server itself, this is back to the original Nginx configuration. From line 10 to line 16, you can see over here that I have a script that allows me to convert my video file into an MP4 file. And once it's done, it will invoke a API call to my node server and push this file into my cloud storage. All right. And this is represented in my cloud storage over here. So on the left side, I have a visualization of the application, the cloud storage application, web application. And you can click into it to find the video file. Once you click into it, they will load it in the browser. So like loading any MP4 files in the browser, you should be able to see it playing like a video player. All right. So with integrating cloud storage and making a little tweak to our application, we can actually create this backup process, making our application even more robust. Okay. And all right. So one last part into our application over here. How do I, now that I've include all these different tools into our application over here, some of you might be asking, this looks like a really complicated architecture. Like all these different infrastructure, all these different tools that you want, it's not easy to bring it up. So yes, that sentiment is correct. And to solve that, we have to use another tool in Google Cloud, all right, which is called Deployment Manager. Okay, so this is similar to other infrastructure as code tools out there like Terraform, but in the context of within Google Cloud. So you can use it as a one-click solution to deploy your entire application. Okay, so to show you a little bit of the configuration, you can use that to, on the left side, you can see over here, this is the deployment configuration YAML file, where I can use, I can put in a configuration like being able to deploy this virtual machine as well as the associated network settings. Okay, and on the right side, of course, not every single resource in Google Cloud can be represented in the deployment manager. So you can also make use of the G Cloud client to be able to run a commands within some shell script to be able to bring up your resources that you need. So by just creating one single shell script, I can use it to create every single resource that I need and also trigger this deployment manager to deploy my application. Right? So we've reached almost the last part of this entire application. And this is the production grade application that we have created. So by using the ecosystem that is Google Cloud, you can pick up different tools. Don't be overwhelmed with the entire suite of tools that we have. You should be able to pick up only the tools you need and use it to create a really good application. All right. So I'm running a bit low on time, so I'm going to fast forward a little bit. You can see over here that we were able to run this in one of our live streams. We're able to stream to 5 different channels, 3 YouTube channels and 2 Facebook pages all at once. All right. So this is all streaming directly from or relaying from Google Cloud. Okay. And just to show you a little bit on the affordability perspective, when we perfected this application, since we're able to encapsulate our application behind Deployment Manager, we were able to make sure that we could bring the system up and down very easily, allowing us, within the long term, you can see that early portions of the project for a single live stream, it could cost around $2 to $3, because we're bringing up the application for a few days. But because we were able to encapsulate that solution to be easily brought up and brought down, we reduced the cost to close to, I would say, 80 cents, 90 cents, 80, 90 cents USD for a single live stream that lasts around for 3 to 4 hours. So again, a very affordable solution, considering that for Streamyard, it costs around $10 to $20 for the next subscription, where we are just hosting, one additional or two additional live streams a month. And I just want to also say that this cost over here that I'm showing you is the raw cost. I took out the discounts, I took out the credits that I'm given, and this is the leftover, the raw cost behind it. But I think for most of us, you will also have, perhaps you're working with a company where you're already given some discounts, or you're already allocated some credits, to try out these applications. By including those, you can actually go as low as no cost for running your application. So again, a very attractive opportunity of using Google Cloud to support your applications at a very, very low cost. So I just want to use this opportunity to mention that you should take note of your free quotas if you're exploring out Google Cloud. If you're just exploring to create some sort of POC, you can try and keep within the free tier so you don't need to pay too much, when you're exploring it. Okay, so I'm going to skip this part because again, we're running low on time, but this one is actually, I'm just saying that, we are not limited by the tools that we can use that I've shown over here. There are all these other tools that we can explore, in terms of cloud monitoring or speech-to-text API in making my application better. Okay, so I am just going to fast forward a little bit just to give you guys a few tips. If you want to get familiarized with using Google Cloud, one huge tip I have is to subscribe to the Quick Labs Twitter account. They do give like free subscription codes every now and then to allow you to try out using Google Cloud. And it's a sandbox environment. It's not like a simple emulated environment where you don't get to use Google Cloud, but you get this sandbox with the guided lab where you can use Google Cloud, the entire Google Cloud environment in its actuality. Okay, so yeah, I'm going to jump to the end if there's any